Hello, everybody. Welcome back to the channel. Today, we're discussing how agents can transform and disrupt supply chain management. And to discuss that, we have Ryuta with us. Ryuta, can you introduce a bit yourself and also the project and the history of the project?
Thank you so much for having me again to this channel. Looking forward to this. And so I work at Databricks as a specialist solutions architect, and I focus on AI and machine learning use cases. I work with customers on a POC, MVP. So about this work that I want to present today, it's a joint work between Puneet, Jane, Dale, and me in the technical part. So what it is an agent that can be used for supply chain management. So it's an agent that's going to be used by logistics managers or supply chain managers. And this agent is equipped with tools that you can use to run simulations. So as if simulations for some specific disruptive scenarios. So imagine that you are a logistics manager and one day you come to the office, you get a phone call from your supplier site saying that their factory caught fire and they're not going to be able to deliver for the next 4 weeks. And now as a manager, you need to make a decision what to do. But first, you need to understand what the financial damage of that disruption mean to your business and what's the best action to take from there. And basically, this agent gives you guidance under such scenario. And so that's what it is. And a little bit about the history, how it came to be. So last time you invited me, I talked about another project called stress testing a supply chain network. And this, the new version of this project is an extension of that previous project. And in the previous project, what we did was we introduced this an approach to basically represent a company supply chain network as a digital twin. And then you start doing a lot of simulation on this digital twin. What if this supplier goes down? What if that group of supplier goes down for this certain amount of time? What is the financial damage caused to the business? And then the idea is to run these simulations as much as possible so that you cover all possible cases. And once you see all the results, you're able to say, hey, this node, actually, we're not spending that much money on risk mitigation, but once it fails, it's going to cause a lot of damage. So let's rethink about the investment for risk mitigation. And what about that supplier side? We're investing a lot, but actually it's diversified. The risk is diversified, so we don't need to spend so much money. Let's take that investment and reroute it to another place. So that was the whole idea of the stress testing of supply chain, but it was really meant to be run on a more strategic scale. The result of the stress testing you would use to negotiate the terms and conditions with your suppliers. For example, you increase the inventory buffer level, or you start thinking about diversifying your supply chain network. But that decision doesn't happen on a daily basis. It might happen once per year, twice per year, maybe quarterly, but it's not something that you do every day. So stress testing was really meant for batch processing. But interestingly, when we were building this solution with one of our customers, we started receiving this request from the business stakeholders. So like supply chain managers and logistics managers, they started asking actually they want to run this every day for very specific scenarios, not, every quarter, every half a year. It's important, but they would also want to run it every day. And then we asked okay, technically it's possible because it's just optimization tool in a cloud compute. You can do it every day. But then why would you want to do that? And they came to us and said, because this kind of disruptive scenario happens on a daily basis. And it's their task to think about what to do when that happens, to first assess the damage, potential damage, and mitigate the risk. So they need to run this solution every day. So that's why they came to us and we said, okay, it sounds like a nice use case for agent. Why don't we ask agent to do this expert task that the real expert sitting somewhere else, busy doing something else, can be, supported by this agentic structure. And that's how we came about building the solution to serve the business stakeholders.
Amazing. Let's jump into the demo to see it, and then we'll have many questions for you.
Yeah, sure. Okay, so this is the blog post that we published. In this blog post, you have access to the code base. It's in the same supply chain stress testing repository, but it's under this agent directory. So what you can do is you can clone this repository and bring it over to your Databricks workspace. And that's what I did here. So you have the stress testing folder. And then inside this agent, you see 3 notebooks. They're meant to be run in sequence. The first notebook is about how to build such an agent. And the second notebook is about how to evaluate it and how to deploy it. And then I'm going to show you how this agent works in action.
Let's see.
Okay. Yeah, let's see. So the first notebook is about building agent. It's just a sort of like a boilerplate code where we're using LangChain LangGraph to construct and build an agent. And here we are using a GPT-5 model that is managed and hosted in Databricks as an LLM endpoint. So this is going to be the brain of the agent. And we're specifying the configurations. And here in the prompt, what's very important is that we are sort of describing the supply chain network already. We're describing what kind of operational data there is, what is the structure of the supply chain, how many tiers exist in the supply chain network. And all of these things are describing the parameters of the operational data that is attached to the supply chain network. For the detail, please look at the previous recording. But yeah, I'm basically providing all information about the parameters and also the decision variables of this supply chain network exercise. So in this demo, what we're going to do is we are going to look into this toy model of a supply chain network, which has multiple tiers. And these gray dots at the top, these are our finished goods. We're producing these finished goods. And the squares in the second layer, these are raw materials that are feeding into our finished goods. And then on the third tier, you can see that these are the raw materials that are being consumed by the raw materials, which in turn will be fed into the finished goods. So you can see this is a multi-tier supply chain network, and each one of these nodes represent different supplier sites. And the color is coded based on the type of raw material. So you can see that these 3 suppliers are producing the same raw material and providing this raw material to different finished goods. Sometimes you see that one finished good is supplying the same material from different supplier sites. So in this case, you can see it as it is the supply is being diversified. And now for each one of these supplier sites, we're collecting different operational data. Very important data is how much inventory is stored at a given time. What is the maximum production capacity and what is the bill of material? So bill of material means which raw material is needed in order to produce 1 unit of a raw material that is produced here. In this case, we need 2 raw materials, this red one and the pink one, to produce 1 raw material here. So these are all the operational data we need to collect. And we're going to create an agent that is able to answer a question. For example, what if this supplier goes down and what should we do? And first of all, what is the financial damage caused by that? Yeah, so this is the front end, the final end product of an agent. This is how the supply chain managers and logistics managers are seeing an agent. This is hosted in Databricks apps. Yes, you can start interacting, ask questions. So for example, I want to ask 1 question. And one of the questions is list all the downstream supplier sites for a specific raw material supplied by this node T310. So T3 and include any related operational information about this site. So I will ask this question and I will let agent respond to this. So agent also has access to data access tool. So it has access to the database that stores the operational information, and it can understand the intent of the business managers and generate a query to respond to that question. So let's see what it answered. So list all the downstream sites for raw material supplied by T3_10, include all related information about this site. So the agent is using this tool called data analysis tool. So this is one of the tools that it has, and it's generating query, and then it's responding to this question. So T25 is the only direct downstream site that receives raw material from T3_10. And it's basically telling us all the information about the operational data that's attached to this specific node. And let's ask another interesting question. Then now I'm going to ask, tell me what happens if one specific site, T2_8, is disrupted and it requires 9 time units to recover. What should I do? So I'm talking about this node, the third from the right. We assume that this node goes down for, let's say, 9 weeks. So what's going to happen to our bottom line? And what's the best action I should take? So let's click
So
on this one.
this, as this runs, so this 9 weeks that you said is something I guess the supply chain manager will know that, okay, this is down. I guess I'm expecting this to come back. Is this information they know about?
Yeah. So this is
Okay.
this information is an input to the
Okay.
model, and it has to be provided by the business. And typically, in some cases, it is captured already in the contract with the supplier.
Mm-hmm. Okay.
Under this condition, we guarantee that the business operates within a certain fixed window of time. So now looking into the output. So yeah, the agent is using an optimization tool. So this is a mathematical optimization tool that basically maximizes the profit under that disruptive scenario.
Is this tool actually hitting the stress simulator?
Yes, it's running the stress testing simulator. Yes, for this one specific scenario. For the stress testing scenario, it was a batch of scenario. But for this agent, it's running it for one specific scenario, for one specific time to recover. In this case, it's 9 units. And so what's happening here is that the agent first is able to understand the intent of the question from the business manager, and it's able to select the right tool. So in this case, it's an optimization tool, and it's not a data analysis tool. And it's also able to select the right input parameters. So it's selecting T2_8 as a disruptive scenario and TTR as 9. And then it runs this optimization. And what happens next is that the result of an optimization exercise is called decision variable. It is basically tells you how much unit needs to be produced at every supplier site and how much unit should be transported from a given supplier site to the downstream supplier site. And that is the, let's say, the value of the decision variable that maximizes the profit. So in other words, you can think of it as this is the recommendation under that specific scenario.
I like that this UI can be used by supply chain managers and that they still can see the traces, because I don't know about you, but at the beginning I thought traces is mostly for developers when they want to debug because, they want to optimize the system or whatever. But I think even non-technical folks, when they see a decision, they don't like to see a black box and not knowing how the agent made the decision. So I imagine it gives them a bit of control to check how it came to that conclusion. So was that a deliberate decision on your side to surface the trace, or was it just for demo purpose?
Yes, it is. It was actually Puneet's works, yes, and it was deliberate intention of his to expose the traces, or more like the steps of how the agent is reasoning against this question. Yeah, that's a spot on. So going back to this decision variable, so what agent has also access to the full decision variable. And by looking at this, since GPT-5 is a really smart model, it can formulate an action plan that the supply chain managers can understand just based on the values of the decision variables. So let's see what that means. So just looking into the optimal decision variable values, it is saying that, okay, first of all, the profit loss that's going to be caused by the disruption of T2_8 for 9 time units will be 1,601 US dollars profit loss. So it's looking at the objective value, function value after the conversions. And it is also telling us, okay, so these are the 3 finished goods units, that are going to lose some unit because of this disruption. So T1_1 will lose units of 4,010 compared against the demand. So we're not going to be able to fill the demand by this unit. T1_3, we're going to lose the demand by 5,137. _8 will completely stop the production because of that disruption. And it is also able to draw up a recommendation for like immediate response, long-term response, and then it's also drawing a summary. And the important thing here is that it is not hallucinating. These recommendations are all based on this deterministic output of the optimization. And since this GPT-5 model has access to all these values, it is grounding its recommendation on the output of a mathematical model. So this is
Very
also
good
very
point on
important.
how to combine the deterministic and non-deterministic word, right? Because in cases where you know what are the steps you need to take to come up with this conclusion, you just need to replicate this in a way that is not different every time you interact with the system. So beautiful way to show how to interact with simulation data points, but any other thing that you have an expertise on, really.
Yeah. Yeah, so this is very important to win the trust from the business.
Mm.
That prove that it's not hallucinating. It's not coming up with this number of 4,010 units out of the blue, but it is the
Yeah.
result of the deterministic mathematical model. Yeah, and it's also requires an expertise in skills and experience to look at the decision variables and to formulate a business action plan. Even for humans, it's not that easy, but GPT-5 models and other smart models can do that like very quickly and very accurately and very thoroughly. So here we have like tens of hundreds of decision variable values, and it can skim through these very quickly and generate this recommendation.
Cool. Amazing. Thanks, Ryuta. So in terms of the architecture behind this product, what is it? Do you want to talk about this, how you implemented that?
Yeah, let's then jump over to the notebook. And yeah, so here we have 3 notebooks. And the first one is about building such an agent. So let's take a look into that. So here we're using LangGraph. So we can use any open source frameworks on Databricks. It could be LangChain, it could be OpenAI, it could be CrewAI. But here we selected LangChain and LangGraph to build such an agent. We're using GPT. And we are defining the optimization tool. So we're defining 2 tools. The first one is called data analysis tool. So this is when your supply chain manager asks about the state of the supply chain network. For example, supply chain manager was asking, show me all the downstream supplier sites of this particular raw material. And then this agent will trigger this tool to tap into the database and retrieve the result.
This
Meaning
is
we're
more around
not predictive. Is that what you mean?
So this contains no optimization. This is no prediction. This is more like, let's say, text-to-SQL
Yeah,
type of tool.
got it.
yeah, interacting with the data.
Yes, you can also plug in Genie API for this purpose as well. And yeah, so this is the part where we have the optimization tool. So we're wrapping the optimization algorithm as a tool. And you can see the details, the function details are all defined inside this utils script somewhere. But yeah, we are basically wrapping those tools with this function and giving it to agent. And here you have this create tool calling agent, defining the nodes. And then, yes, so this is the class that does the supply chain agent. And we have to predict and predict stream method applied. And then the rest is your standard MLflow Databricks approach.
So the way you wrap the optimization function into the tool, is it just hitting another, let's say, MLflow artifact, or you literally wrap the code of the optimization into that?
Yeah, it is literally wrapped into this optimization tool. And I'm also loading those custom libraries that has the definition of the tool together with my model artifact using MLflow.
Okay. Cool.
Yeah. And the detail about the algorithm, I think I talked about it in the first video, so we can look into that. So this is...
So yeah, for this video, the supply chain optimization part is kind of, let's say, abstracted because we have deep dive in another video. We're just executing this at this point through the agent. We use the agent to create the parameters to execute this optimization simulation.
Yes, that's correct. Yeah. So here, yes, we're using MLflow to log that agent and then eventually registered it into Unity Catalog. So that was the building agent part. And the most important part of this project is probably evaluating if your agent is actually choosing the right tool, choosing the right parameter. And for this, we use agent evaluation. So this is described in this second notebook. We're not going to go into the details of it, but I just want to show you the evaluation data set that we used to measure the performance of this agent. So in this evaluation data set, we synthesized a typical question that you would ask or the managers would ask to an agent. So here you can see that question that I was asking in the front end. What are all the downstream production sites? And then in this expectations clause, I'm defining which tool should the agent choose in order to answer this question. So I know that for this question, agent needs to choose the data analysis tool. But for this question, what happens if T2_8 is disrupted? I know that the agent should choose the optimization tool instead of data analysis tool. So providing this ground truth label so that later on I can evaluate, looking at the trace and say, did you choose the right tool? Yes or no?
Are we having evaluation scores only for if the tool choice was correct or not? Even if let's say if the tool choice was correct, the answer at the end of the day.
Yes. So for this specific scenario, we have two custom evaluation scores. So one is if the tool that the agent chose was correct or not. And there's a ground truth label for that. And the second question is if the input parameters are correct or not. And of course, yes, I can also come here and define another field called expected input parameters.
This is for if the optimization tool was chosen, if the optimization parameters were actually fetched correctly.
Yes, exactly.
Yeah.
Yeah. And for the latter case, you can see that I'm not providing the ground truth. What I'm doing is I'm calling an LLM to look into the question and look into the parameter that I chose and asking an LLM as a judge to make an inference about the correctness of the selection of this parameter, so that even without a ground truth, I'm able to measure how accurate the agent chose the input parameters.
Just wanted to add that if people want to learn more about how to evaluate agents, we're going to release a video very soon where we interviewed Samraj from the MLflow team at Databricks that deep dives into all those features in details. So you can watch that video to learn more.
Yeah, there's a lot of cool things hidden there. Yeah. And also other scores are like, so this is the tool parameter score that I was just talking about. And here is the response time. So is it taking longer than 120 seconds? Yes or no? And this is, again, like this has nothing to do with an LLM. It's just looking into the meta information about the trace, how long it took, and then, defining a logic to say it was longer or shorter than 120 seconds.
Nice.
And in the end, I can put all these guidelines and my custom scores into the scores list and run GenAI Evaluate. And that would produce results for that 5 test use cases that I defined above.
Beautiful.
Amazing.
Yeah. And the deployment notebook, I'm going to just skip this because it's just about this agent.deploy and then put it behind a model serving endpoint.
Okay, basically the architecture of the agent is an agent with tools. One tool is about fetching and understanding more text-to-SQL queries from the user. The other tool is more around running the simulation of the disruption in the supply chain and the impact that will have. And part of the logic here is to allow the model itself to understand the user requirement and turn this into the parameters for the optimization.
Yeah, that's right. And it's ultimately what it's doing is it's bringing like this sophisticated optimization algorithm in the hand of business users so that it can be executed anytime they want.
Cool. Completely abstracted.
Yeah. Yes, that's right. And maybe like 2 directions that we're thinking to expand this project towards. So one is this image. This is kind of like the image that we have in our head, Dale, Puneet, and I, is that now what happens if we let this agent loose on the database of contract? And these contracts store supplier conditions and terms and conditions with the supplier. And this agent will go around and find a contract that would expire in a few months so that the managers could start thinking about renegotiation. And for that specific contract supplier, it would run multiple simulations from different angles, different time to recover, different time to survive, and expose different scenarios and come up with a suggestion. For example, in the previous contract, this clause was not mentioned. For example, inventory buffer or TTR. For the next version, you should consider including this in a clause.
Very nice.
So yeah, this will open up a whole new application here as well.
Amazing. Thanks.
Amazing. Thanks, Ryuta.